The truth is out there, and so is the future. Welcome to Genii Cafe, where we explore the strange, the powerful, and the unexplained world of generative AI. With your host Nico Peters, and in each episode, we'll uncover how artificial intelligence is reshaping our reality, pushing the boundaries of creativity, and challenging everything we know. Are we witnessing the dawn of a new era, or playing with forces we can't control? Stay tuned and prepare yourself to venture beyond the edge of innovation, where technology meets the unknown.
Voice recognition technology has dramatically reshaped the landscape of human-computer interaction. In an era where efficiency and convenience are paramount, voice recognition serves as a crucial catalyst, enabling seamless communication with devices at the touch of a button, or often without any button at all. At its core, voice recognition involves the capability of a machine or software to interpret human speech and transform it into a format that is comprehensible to a computing system. This technology hinges on the principles of machine learning and natural language processing, allowing computers to decipher and execute commands from spoken language accurately. One cannot overlook its prevalence in today's digital space. From asking virtual assistants like Siri, Google Assistant, or Alexa to perform mundane tasks to driving cars or managing smart homes, voice recognition enhances user experience by making interactions more intuitive and less reliant on manual input. The integration of voice recognition into daily life is also evidence of its growing importance. Businesses leverage it for customer service automation, enhancing user accessibility and refining search engines, while developers continue to expand its potential applications. Despite these advancements, the deployment of voice recognition technology is not without its challenges, ranging from language and dialect variations to privacy concerns and technological limitations. As we delve deeper into the nuances of this evolving field, it's essential to recognize both its capabilities and areas needing improvement. With a foundational understanding in place, our next exploration will involve dissecting the technical components that make voice recognition possible, setting the stage for a greater appreciation of its sophisticated framework and how it responds to diverse user needs. Let's delve deeper into the technical components of voice recognition systems. To understand how these systems excel at comprehending human speech and responding appropriately, it's essential to explore several key technical aspects, including signal processing, acoustic modeling, and natural language processing, NLP. First, signal processing is a critical step where the system converts spoken words into a digital form that can be analyzed. This involves filtering out background noise, normalizing volume levels, and identifying key speech frequencies that aid in distinguishing different sounds and words. Filtering and noise reduction ensures improved clarity by effectively isolating the speaker's voice from surrounding noise. Volume normalization maintains consistent audio quality that facilitates better interpretation. Frequency analysis differentiates between various speech sounds to enable accurate recognition. Next, we have acoustic modeling, which plays a pivotal role in deciphering the sound patterns of speech. Acoustic models are trained using vast datasets spoken language to understand the nuances of speech phonetics. This knowledge helps in mapping audio signals to linguistic units such as phonemes. Phonemes identification breaks down speech into the smallest sound units for better comprehension. Model training involves feeding the system extensive audio data to train the model on various speech patterns and accents. Finally, while we just touched upon NLP in passing, this component tightly integrates with the aforementioned processes to interpret and generate human language meaningfully. However, I will elaborate on its role in voice recognition systems later on. Each of these elements, signal processing, acoustics, and modeling, NP, interact harmoniously to enable systems to deliver efficient and accurate voice recognition. This intricate dance of technology ensures that machines can understand and respond to human speech in a way that feels almost seamless. Transitioning smoothly from the last topic, let's delve into the indispensable role of natural language processing, NLP, in voice recognition technology. As we navigate this segment, it becomes clear that the inherent complexities of human language present unique challenges for NLP. NLP serves as the backbone for interpreting voice input, essentially acting as the bridge between human language and machine comprehension. By leveraging sophisticated algorithms, NLP transforms unstructured voice data into structured information to recognize, understand, and to spoken commands accurately and efficiently. This is no small feat. Human language is full of nuances, context, and variation. To thrive in a voice-based interaction environment, NLP needs to tackle layers of language interpretation, syntax analysis. This involves parsing sentences to understand grammatical structure and rule out ambiguities. Semantic understanding. This layer focuses on the meaning of words and sentences essential for deriving context. Pragmatic and discourse processing. Here, the focus is on understanding the use of language in real-world scenarios, taking into account context, tone, and intent. Moreover, NLP is capable of learning from interactions, improving over time with exposure to different dialects, accents, and languages. This adaptability is crucial in creating systems that cater to a global audience with varied linguistic backgrounds. In essence, effectively managing these tasks allows NLP to facilitate a seamless and intuitive voice-based interaction between users and devices. As we further explore the technical intricacies of voice recognition, we will now shift our focus to understanding how acoustic modeling plays a critical role in this fascinating technological landscape. Acoustic modeling plays a pivotal role in the process of converting voice signals into text. It is essentially the backbone of voice recognition technology, providing the framework that interprets sound waves and converts them into phonetic units. So what exactly does an acoustic model do? In essence, it learns to recognize patterns within audio signals and maps these patterns to specific phonetic units of speech. This mapping is not straightforward, as speech is influenced by multiple factors including accents, beat of speech, and environmental noise. This complexity is why acoustic models are designed to be sophisticated and highly adaptable. To create an effective acoustic model, data is paramount. Large datasets comprising diverse voice samples are used to train the model. The training involves teaching the system to understand the variations in speech and noise, thereby making it robust enough to handle real-life scenarios. Let's not forget that acoustic modeling is inherently tied to machine learning. Algorithms such as hidden Markov models, HHMM, and deep neural networks then are employed to improve the accuracy of voice recognition systems. These algorithms help the model in learning subtle nuances in speech, enhancing its ability to differentiate between similar sounds. Despite its importance, acoustic modeling still faces significant challenges. One such challenge is developing models that can effectively generalize across languages and dialects, making voice recognition systems universal and more inclusive. In summary, acoustic modeling forms a critical component of voice recognition by breaking down complex audio signals and associating them with textual representations. This is indispensably linked to the broader goal of creating systems that can understand natural speech with high accuracy. As we delve deeper into the intricacies of voice recognition technology, one major aspect that needs attention is signal processing. Signal processing forms the backbone of voice input analysis, converting audio signals into a format that machines can interpret and work with efficiently. At its core, signal processing involves several key stages, each crucial in ensuring that the voice input is clear, accurate, and ready for further processing. These stages include noise reduction, echo cancellation, and signal enhancement noise reduction. This step involves filtering out irrelevant background noise to focus on the primary audio signal. Advanced algorithms can distinguish between voice and non-voice components, enhancing the clarity of the desired input. Echo cancellation: here unwanted echoes are removed which can otherwise distort the audio signal. This process is particularly important in scenarios where speakers interact with devices in reflective environments. Signal enhancement: finally, the audio signal is refined to improve its quality. This might include adjusting the frequency response and filtering to ensure the voice signal is as precise as possible. These enhanced signals are then further analyzed to extract meaningful patterns and features, a process integral to enabling accurate voice recognition. The processed signals serve as the foundation for succeeding stages like feature extraction and pattern matching within the recognition framework. By optimizing signal processing technique, we can maximize the accuracy and efficiency of voice recognition systems. This ensures that devices can interpret voice inputs with increased accuracy, paving the way for more effective applications. As we explore how this technology translates into real-world uses, let's turn our attention next to its practical applications. Clearly, the landscape of voice recognition is vast and varied, each application shaping a more responsive and intuitive interaction framework. As we move on, it's crucial to recognize how this technology is intersecting with domestic and personal tech innovations. Transitioning into our next discussion, let's delve into how virtual assistants and smart devices intertwine with and expand upon these groundbreaking applications. In today's interconnected world, virtual assistants and smart devices have seamlessly integrated voice recognition into their core functionalities. This integration has revolutionized how users interact with technology, making everyday tasks more convenient and intuitive. Virtual assistants like Amazon's Alexa, Apple's Siri, Google's Assistant, and Microsoft's Cortana have set the benchmark for voice-driven interaction. These intelligent systems are capable of understanding and executing a diverse range of commands, from setting reminders and playing music to controlling smart home devices and providing weather updates. Their ability to process natural language makes them invaluable tools for users seeking hands-free assistance. Smart devices ranging from televisions and thermostats to lights and refrigerators now come equipped with voice recognition capabilities, offering users unprecedented control over their environment. This functionality goes beyond simple command execution, enabling complex automation sequences that enhance user experience. Moreover, the integration of voice recognition technology in smart devices goes hand in hand with advancements in AI and machine learning. As these technologies evolve, virtual assistants and smart devices can offer more personalized experiences, adapting to users' preferences and habits. The enhanced user experience provided by voice recognition technology in virtual assistants and smart devices represents a significant leap towards more interactive and intelligent home and work environments. This seamless integration makes technology more accessible and intuitive, urging the development of more sophisticated applications. Building on the role of intelligent virtual assistants and smart devices, voice recognition technology is making significant strides in enhancing accessibility for individuals with disabilities. This advancement not only aids communication but also promotes greater independence and inclusivity across various life activities. Let's explore how voice recognition is transforming accessibility in different domains. Firstly, consider those with physical disabilities that limit their mobility. Voice commands can control smart home devices, enabling individuals to turn on lights, adjust thermostats, or manage entertainment systems without the need for physical manipulation. This aligns with creating an environment where everyone can manage their surroundings autonomously. Next, for individuals with visual impairments, voice recognition technology is a game changer. By integrating with screen readers and other applications, it allows users to interact with their devices seamlessly, providing them the ability to send texts, navigate the internet, and access a wide array of audiobooks with minimal friction. Those dealing with speech or hearing impairments also find utility in advancements in voice recognition. While it might seem counterintuitive, advanced speech to text capabilities allow spoken words to be converted into text in real time, facilitating smoother communication for those who can speak but have difficulty being understood, or vice versa. Moreover, educational environments are witnessing transformations. Students with learning disabilities can now leverage voice-to-text tools to assist in drafting assignments, taking notes, and efficiently articulating their ideas without being hindered by dyslexia or other similar conditions. Such innovations do not just simplify tasks, they empower users, enhancing their quality of life and enabling them to participate more fully in society. In the following part of this podcast, we will delve into some of the prevailing challenges facing voice recognition technology, highlighting areas that necessitate further innovation to ensure even more inclusive and seamless usage. One of the significant challenges facing voice recognition technology is its ability to accurately interpret diverse accents. As the technology aims to serve a global audience, it becomes crucial to accommodate the variations in pronunciation and speech patterns without compromising accuracy. This is no small feat, as it requires extensive datasets and robust machine learning algorithms that can adjust to these differences effectively. Moreover, maintaining user privacy is another daunting task, with voice recognition devices often needing to be always listening. Ensuring that sensitive data is not inadvertently shared or stored becomes a priority. Companies must develop secure methods for handling voice data, but striking a balance between functionality and privacy protection continues to be a significant hurdle. Furthermore, the presence of bias in voice recognition technology is a pressing issue that needs to be addressed. Bias can emerge from inadequate training datasets that don't represent the full spectrum of user demographics. This can lead to unfair treatment or inaccuracies for specific groups, making it essential to ensure that the systems are designed inclusively. By acknowledging these biases, developers have the opportunity to rectify them and create more equitable technologies. Given these challenges, it is evident that continued innovation and vigilance are necessary to enhance the performance and fairness of voice recognition technology. However, the solutions to these problems also raise questions about ethical concerns and privacy issues, which are also integral to the development of these systems. As we move forward, these elements must be addressed in tandem with technological advancements to ensure responsible deployment and user trust. As we delve into the realm of voice recognition technology, ethical concerns and privacy issues stand prominently in discussions. The increasing adoption of this technology in daily life raises several pivotal questions regarding privacy and data security. One major ethical concern is the potential misuse of recorded voice data. Companies and developers must ensure that the data collection is transparent and permissions are explicitly granted by users. Without stringent measures, there's a risk of voice data being used for purposes beyond the original intent. Another pressing issue is data security. Voice recognition systems often rely on cloud storage to process and analyze voice commands. This makes them vulnerable targets for cybercriminals who could gain access to sensitive personal information. Therefore, implementing robust security protocols is essential to protect user data. Furthermore, there's the concern of constant surveillance. As voice-activated devices become commonplace, the fear of being constantly monitored grows. Users worry about potential eavesdropping and the recording of conversations without explicit consent. To address these concerns, regulatory framework and guidelines need to be established. Policymakers must work alongside tech companies to create laws that protect user privacy and define the ethical boundaries for voice data usage. Finally, educating consumers about the risks and best practices for safeguarding their privacy is vital. Users should be aware of how their devices operate, what data is collected, and how it is used, giving them control over their personal information. By acknowledging and addressing these ethical and privacy issues, we can pave the way for responsible innovation in voice recognition technology. In the next section, we will explore the emerging innovations that aim to enhance this technology further while addressing these concerns. Now, as we advance beyond the ethical implications of voice recognition technology, let's pivot our attention to the emerging innovations that are transforming this field. These innovations are not just enhancing the functionality of voice recognition systems, but are revolutionizing the way we interact with technology as a whole. One key innovation is contextual awareness. Voice recognition systems are evolving to understand not only the words we say, but also the context in which they are spoken. By interpreting environmental cues or previous interactions, these systems can provide responses tailored to specific situations. Imagine a smart assistant that can adjust its responses based on whether you're at home, at work, or even in a noisy environment. Another exciting development is emotional analysis. This innovation focuses on detecting and interpreting the speaker's emotions through vocal tone, volume, and speech patterns. This could enable more empathetic interactions where technology can respond not just to what is said, but how it is said. For instance, detecting frustration could prompt an assistant to offer additional help, or understanding excitement might suggest enhancements to a user's experience. Moreover, these advancements are expected to enhance accessibility, making technology more intuitive for users with disabilities. Contextual awareness and emotional analysis can work together to create more seamless interactions, potentially revolutionizing customer service and personal assistant applications. But how will these innovations integrate into the everyday technology landscape? It's precisely where the future lies, a future where voice recognition technology becomes an indispensable tool across industries. And speaking of the future, let's delve into what the coming years hold for voice recognition technology in our next section. As we gaze into the horizon of voice recognition technology, it's clear that its progression is far from peaking. With continuous advancements in artificial intelligence and machine learning, voice technology is poised to revolutionize multiple facets of daily life and industry. In the not-so-distant future, we might see voice recognition systems that are impeccably accurate, with every unique voice profoundly intuitive, responding not just to words but also to emotions and context, and seamlessly integrated with a myriad of devices and platforms, fostering true interconnectivity. The implications of these advancements are vast. Imagine healthcare systems empowered by voice technology, providing clinicians with real-time analysis and suggestions during patient consultations. Or educational environments where voice recognition aids in personalized learning, adapting to the nuances of each student's speech patterns and learning pace. Moreover, as privacy concerns loom large, the future could entail more robust encryption and secure voice data management, safeguarding user interactions without compromising on functionality. Advances in adaptive learning algorithms might also see systems that continually learn and refine themselves with each interaction, mimicking human learning processes. Ultimately, the potential for voice recognition technology is limited only by our imagination. As we wrap up this exploration of voice recognition technology, one thing remains certain: the future promises to be as exciting as it's transformative. This journey, with all its challenges and breakthroughs, emphasizes not only technology's capabilities but also its profound impact on the way we live and interact with the world around us. Thank you for joining us on this exploration, and stay tuned as we continue to navigate the technological frontier.